Welcome to Lesson 3, Life Cycle Ownership. We now know what an FDE is and why ordinary handoffs can lose the conditions that determine whether a deployment works. This lesson connects the individual activities into one end-to-end operating loop. An FDE engagement is a sequence of decisions. Satish advances only when the current stage produces enough evidence for the next commitment. That sentence is important because an engagement is not a fixed project plan that becomes true when someone approves it. The plan changes as customer, system, and production evidence improves. At every stage, Satish asks 4 things. The question identifies what must be learned before the next commitment is responsible. During discovery, the question may be which decision coordinators are actually making. During a pilot, it may be whether stale qualification data creates unsafe recommendations. The work is what Satish and the surrounding team do to reduce that uncertainty. Work can be observation, data profiling, API testing, architecture, coding, evaluation, training, deployment, or incident response. Activity is not progress unless it changes what the team can decide. The evidence is the inspectable result. A workflow map, source profile, tested contract, trace, evaluation report, owner record, pilot metric, or incident review can support a decision. We discussed it, the demo looked good, and the model usually gets it right are not strong evidence. The exit is the decision created by that evidence. Advance when the next stage is justified. Narrow when value remains, but scope or authority must shrink. Run a technical spike when one uncertainty needs a bounded test. Pause when an owner or dependency is temporarily missing. Stop when a critical safety, legality, or production condition cannot be established. The 6 stages are understand, bound, build, operate, prove, and return. They form a loop rather than a rigid waterfall. New production evidence can send Satish back to the boundary or even to the original workflow understanding. End-to-end ownership means preserving the reasoning across those movements. Stage 1. Understand begins with the decision, not the requested feature. Observe the decision before proposing the system. Satish reconstructs how a coordinator turns an incident into a dispatch action. First, identify the user and trigger. The primary user is an IST service coordinator. Work begins when a new equipment incident enters case desk or an existing incident changes severity. But not every incident needs a dispatch decision. Some are duplicates, some can be resolved remotely, and some require immediate safety escalation. The trigger must specify when assistance is useful. Next, record the evidence inspected. A coordinator reads the incident description, identifies the asset in Asset Vault, checks procedures in Manual Hub, searches technician qualifications in Skill Roster, checks schedule and distance in Dispatch Board, reviews previous service history, and sometimes calls a regional expert. Some evidence comes from systems, some lives in user memory. Satish records source authority, access, freshness, missing values, and contradictions instead of treating every field as equally trustworthy. Then observe the judgment. Experienced coordinators do not merely match keywords. They reason about equipment type, symptom severity, warranty, technician certification, travel time, parts availability, repeat failures, customer priority, and exceptions. Some rules are explicit, others are learned through corrections. Satish asks users to explain difficult and borderline examples, not only the normal path. He compares what people say with what they actually inspect and change. Finally, trace the action and feedback. The coordinator may request remote troubleshooting, propose a trench, escalate to safety, schedule a visit, or ask for more information. Later evidence shows whether the action worked. The technician accepts or declines, the incident is reassigned, the repair succeeds, or the diagnosis changes. Without the feedback loop, the team cannot define a useful evaluation target. The output of understand is an evidence-backed decision map. It includes the user, trigger, workflow, systems, decision criteria, exceptions, consequences, baseline, and unresolved questions. The exit is not discovery meetings completed. It is a decision about whether there is a coherent, valuable problem worth bounding. Stage 2. Bound turns discovery into a thin deployment contract. The first release improves one decision for one user under explicit authority and stop conditions. Start with one user. The pilot is for trained IST service coordinators, not technicians, customers, managers, or every employee who can open an incident. A bounded user group makes identity, permissions, interface design, training, support, and feedback measurable. Choose one decision. The first deployment recommends a triage path: request more information, attempt approved remote guidance, propose dispatch review, or escalate. It does not autonomously select, schedule, and notify a technician. The narrower decision still creates value because it reduces evidence gathering and makes next steps more consistent. Define human authority. The coordinator reviews sources, sees limitations, modifies or rejects the proposal, and remains responsible for the operational decision. Safety escalation cannot be bypassed. Software may prepare a proposal, but the authority boundary is encoded in permissions, interface actions, audit events, and runbooks, not merely stated in a slide. Write the non-goals. No automatic scheduling, no customer notification, no work order creation, no advice outside approved procedures, no use for restricted equipment categories, no claim that the assistant replaces coordinated judgment. Non-goals prevent adjacent expectations from entering the pilot without evidence and ownership. Specify stop conditions. The system abstains if asset identity is ambiguous, qualification data exceeds its freshness limit, required evidence is missing, the retrieved procedure is not applicable, the validator rejects the structured output, or a restricted safety rule applies. The pilot itself pauses if unsafe suggestion rate exceeds threshold, trace coverage drops, support ownership disappears, or users cannot distinguish suggestions from authorized actions. The thin deployment contract also names the cohort, incident segment, sources, interfaces, success measures, guardrails, owners, timeline, and reversal condition. The exit from bound is an explicit commitment. Build this test with these authorities and limitations to answer these questions. If the contract cannot be made coherent, Satish narrows, spikes, or stops before code creates false momentum. Stage 3, build, creates the smallest complete deployment that can test the bounded assumptions. Build the deployment around the model. Satish integrates data, permissions, retrieval, validation, user review, and telemetry. Contracts define inputs, outputs, errors, versions, and ownership. The incident request includes tenant, actor, case identifier, correlation identifier, and requested operation. The response is a structured triage proposal with evidence, references, limitations, confidence indicators that have defined meaning, and an abstention reason. Error contracts distinguish unavailable data, unauthorized access, invalid input, model failure, validation failure, and policy refusal. Integration connects customer systems and identity. Satish authenticates the coordinator, enforces tenant and case access, retrieves the current asset record, obtains applicable procedures, reads qualification freshness, and handles timeouts or schema changes. Integration code needs retry policy, idempotency, rate limit handling, mapping tests, secrets management, and observability. A successful happy path API call is not a production integration. The AI proposal is deliberately bounded. Retrieval supplies applicable procedures with provenance. The prompt states the task, allowed evidence, output schema, abstention rules, and prohibited behavior. The model returns a proposal rather than executing an operational action. Model selection is based on evaluated behavior, latency, cost, and operational fit, not brand preference alone. Control remains outside probabilistic generation where deterministic rules are available. Schema validation rejects malformed output. Policy checks enforce restricted equipment and qualification freshness. Tool authorization limits what can be read or proposed. The coordinator interface exposes evidence and requires an explicit decision. Fallback returns the workflow to normal operation. Observation makes the deployment diagnosable. A trace links actor, incident, source versions, retrieval results, results, model and prompt version, output, validation results, user action, latency, errors, and eventual outcome. Evaluation cases are created from meaningful failures. Without observation, the team can demonstrate behavior but cannot operate, improve, or defend it. The build exit is not features complete. It is readiness evidence showing that the thin slice works across expected and failure paths, respects authority, produces complete traces, and can enter a supported pilot. Stage 4. Operate is where the demonstration becomes a supported pilot. Real users need training, support, fallback, alerts, recovery, and accountable owners. The cohort is intentionally limited. IST selects trained coordinators, approved regions, low-risk equipment categories, and incident segments represented in evaluation. User and case eligibility are enforced in software. The team knows exactly who can see the assistant, which requests count toward pilot measures, and how to remove access. Readiness includes more than pre-production tests. The release checklist confirms data freshness monitoring, authorization, traces, dashboards, alerts, support contacts, on-call expectations, fallback, rollback, user training, incident communication, and named customer owners. Coordinators practice accepting, modifying, rejecting, and escalating proposals. Support practices reconstructing a failure from a trace. Exposure controls how quickly the workflow depends on the system. Shadow mode generates proposals without showing them to users, allowing comparison with real decisions. A canary shows the assistant to a small group or segment. A limited pilot increases exposure only after thresholds hold. Feature flags and eligibility rules make expansion and rollback reversible. An incident is treated as production evidence, not embarrassment. Suppose qualification freshness monitoring fails and a stale recommendation reaches a coordinator. The team contains exposure, disables the affected path, communicates with users, preserves traces, identifies the control failure, recovers safely, and adds a regression evaluation. The question is not whether failures occur, it is whether the operating model detects, limits, explains, and learns from them. Satish remains close to coordinators during the pilot, but the goal is not permanent dependency on Satish. Runbooks, dashboards, ownership, and escalation paths transfer expected operation to IST and platform teams. The operate exit requires sufficient real workflow evidence and a functioning ownership model, not simply elapsed pilot time. Stage 5. Prove separates technical performance from customer impact. Technical quality and customer impact are different evidence. A passing model does not prove adoption, workflow improvement, safety, or business value. Model quality measures behavior against a representative, versioned evaluation set. IST tracks correct triage category, unsupported claims, grounding failures, incorrect procedure use, unsafe suggestions, abstention quality, and performance by incident segment. Aggregate accuracy alone can hide the rare category that carries the greatest consequence. Workflow quality measures what happens around the proposal. How long does a coordinator take to reach a correct triage decision? How many systems must be opened? How often is a recommendation reassigned, escalated, or corrected? Does the interface make missing evidence visible? A model improvement that adds explanation but increases handling time may not improve the workflow. Adoption distinguishes availability from useful use. Satish measures eligible sessions, proposals viewed, acceptance, modification, rejection, escalation, abandonment, and reason codes. Overrides are not automatically failures. An override can reveal a legitimate exception or missing evidence. Interviews and observation explain the behavior behind the numbers. Trust is not measured by asking users whether they like AI. It is inferred from appropriate reliance and correction. Outcome connects the deployment to the customer objective. IST may target lower time to correct triage, fewer avoidable reassignments, faster first response, and stable safety performance. The analysis states baseline, sample, time window, confounders, and limitations. It avoids claiming revenue or customer satisfaction impact that the pilot cannot isolate. The proof decision can be expand, continue, revise, narrow, or stop. Expansion requires thresholds across capability, safety, workflow, reliability, adoption, and outcome. One strong metric cannot cancel a failed guardrail. The artifact is an evidence review that another technical or operational owner can inspect and challenge. Stage 6. Return prevents fieldwork from becoming an accumulation of private branches. Customer-specific work should create reusable learning. Satish separates local integration from platform capability, evaluation assets, and product gaps. Local integration includes IST-specific endpoints, field mappings, identity rules, network configuration, and operational contacts. These artifacts need an explicit customer or delivery owner. They should not silently enter the core product, and they should not depend forever on undocumented knowledge in Satish's head. A reusable pattern is a repeatable method that can help future deployments. The decision map template, freshness contract, proposal versus action tool boundary, pilot exposure plan, trace schema, or engagement scorecard. A pattern becomes reusable when its assumptions and limits are documented, not when code is copied without context. A platform gap is a missing capability that multiple deployments need. IST may reveal that the platform lacks source freshness policy, provenance display, tool authorization, evaluation versioning, or replayable traces. Satish supplies field evidence, affected workflows, acceptance criteria, and interim risk. Product and platform owners decide whether and how to build the durable capability. An evaluation asset is a failure case worth preserving. A stale certification, ambiguous asset identity, conflicting procedure, unauthorized action request, or misleading explanation becomes a sanitized test case with expected behavior. Evaluation assets allow future model, prompt, retrieval, and code changes to be judged against real deployment risk. A model limitation is behavior that changes architecture or positioning. If the model cannot reliably abstain under conflicting procedures, the system may need stronger deterministic gating or a narrower use case. The learning is not the model is bad. It is a reproducible boundary and the control required around it. Return also includes operational handoff, documentation, ownership, backlog, outstanding risks, cost evidence, and the conditions for future expansion. The engagement succeeds when customer value remains operable and the organization is smarter after Satish leaves. We can now make the lesson decision. What must be true before the engagement advances? Attach an owner, artifact, and exit decision to every lifecycle stage. Advance when the required evidence is present. Understand advances with a verified decision map and valuable problem. Bound advances with an approved thin deployment contract. Build advances with readiness evidence. Operate advances with stable, supported pilot evidence. Prove advances with accepted outcome and guardrail results. Return closes with ownership and reusable learning. Narrow when the evidence supports value but not the original scope. IST can remove restricted equipment, keep a coordinator approval, reduce the user cohort, use fewer sources, or recommend triage instead of technician assignment. Narrowing is a disciplined response to evidence, not a failure to deliver ambition. Run a spike when one technical uncertainty blocks a responsible commitment. Satish might test whether skill roster freshness can meet policy, whether asset identity can be resolved, whether a procedure can be retrieved with sufficient precision, or whether a model can produce the required structure. A spike has one question, bounded time, representative data, success criteria, and an explicit next decision. It is not an open-ended prototype. Choose pause or stop when critical ownership, authority, data access, safety evidence, or production support is absent. Pause when the condition can plausibly be restored. Stop when the engagement would require an unsafe action, unlawful access, misleading promise, or unowned permanent branch. The complete operating loop is understand, bound, build, operate, prove, return. Notice that coding is central but not isolated. The FDE owns the reasoning that connects the customer decision to the code to production operation, and production evidence back to the product and customer. For your engagement stage map, write one row per stage. Name the question, work, evidence artifact, owner, exit criterion, and current decision. If any row ends with "we will know when we get there," the engagement is not yet controlled. In the next lesson, we will compare this ownership model with adjacent technical roles using observable work rather than titles.